Today we're going to put together everything we've learned about solving two-step and multi-step equations and inequalities, what we've learned about inequalities. We're going to follow the same rules that we did for solving multi-step equations. So look at the three big ideas that I have listed. First of all, as I just said, we're following the same steps we did for multi-step equations, and those steps are, first of all, you have to distribute. Second step, you're going to combine like terms. Step 3, you'll collect variables. Step 4, undo addition or subtraction. Step 5, undo multiplication and division. Step 6, check your answer. If you don't remember these steps, you need to look back in chapter 1 or in your notes. You need to know these steps. You will be using them. Secondly, you need to remember to reverse the inequality sign when you multiply or divide by a negative number. This is not true when adding or subtracting by a negative, only when multiplying or dividing by a negative number. So you reverse the inequality symbol. And finally, step 3, remember to check your solution by checking the endpoint and the inequality symbol. And you check the inequality symbol by picking a point from the shaded region to see if it makes your inequality true. Here's an easy example. In this example, we have 45 plus 2b is greater than 61. First, we undo addition and subtraction because there are no distributing to do. There's no like terms. We do not have variables on both sides. So minus 45 from each side. That makes our 45s go away on the left. They're opposites. And on the right hand side, 61 minus 45 is 26. Now we have 2b is greater than 26. Divide both sides by 2, and we get our solution. B is greater than 13. I'm not going to graph this right now. We are going to erase our lines. Well, maybe not. Maybe we'll just go on to the next page. We're not going to graph this, but you can do that on your own. You know how to do that. In the second example, 8 minus 3y greater than or equal to 29. Just as you would if this were an equation, we will subtract 8 from each side, giving you negative 3y is less than 21. Next, we're going to divide both sides by negative 3 because that undoes the multiplication. Remember, however, when you divide by a negative number, you will reverse the inequality sign. So the greater than or equal to becomes less than or equal to. Right there, we have flipped our sign. Finally, we get our resulting answer. Y is less than or equal to negative 7. And we're going to graph this and check our endpoints and our sign. Our endpoint is at negative 7. So we are going to graph to the left. That's where we find our point less than negative 7. Okay? We're going to check our endpoint and check our sign. To do this, put a negative 7 in for y. So 8 minus 3y is greater than or equal to, gotta make sure we use the original sign, 29. We're going to put negative 7 in for y. That gives us 8 minus 3 times negative 7 is greater than 29. Excuse me, greater than or equal to. Okay, negative 3 times negative 7 is a plus 21. So 8 plus 21 is 29, and our endpoint checks. Next, we will pick a point in our shaded region to see if it makes our statement true. Well, let's take a look. Negative 10 is in our shaded region. So let's put negative 10 in for y up here. 8 minus 3 times negative 10. We'll see if that's greater than or equal to 29. Negative 3 times negative 10 is plus 30. So we have 8 plus 30 is greater than or equal to 29, and that checks because 8 plus 30 is 38, and that's greater than or equal to 29. In this example, we're doing more of the same. Actually, what we're practicing is our skills in solving equations. What we need to do here is simplify on the left by combining like terms. Where do we get the 12? Well, 2 minus negative 10 becomes 2 plus 10, which is 12. So that's where we get our 12. And then we divide by negative 4, both sides, giving us negative 3 is less than t, because remember, we have to reverse our sign. We started out with greater than, and now we have less than. Our answer becomes less than. And why did I flip it here? Because I want to make sure my variable is on the left. See, t, the arrow points to the negative 3. So when I flip it, I get t greater than negative 3. And then I'm going to graph it and check my solution. Okay, negative 3 is my boundary point. I'm shading to the right. That's where I find my values greater than negative 3. Check my endpoint in the original equation. So I have 2 minus a negative 10, which is 12. And that is greater than or equal, greater than negative 4 times negative 3. Negative 4 times negative 3 is 12. Sorry, you'll have to imagine that. 12. That means my endpoint checks. Now to pick a point in the shaded region to see if that checks, I'm going to pick 0. I always like to pick 0. But then in my original equation, 12 is greater than negative 4 times 0, which is 0, and 12 is greater than 0. So I shaded correctly. The final example. Bear with me. Oh, here we go. Here we go. Final example. This is a fun example that involves fractions. In this example, I have 2/3 f. I'm going to rewrite this. 2/3 f plus 1/2 is greater than 1/3. Well, first of all, I really would rather not work with fractions. To get rid of my fractions, I'm going to multiply both sides by 6, which is the least common denominator. So I'm going to multiply the left-hand side by 6. Okay, this is just getting annoying. So we're going to multiply the left-hand side by 6 and the right-hand side by 6. But when you do that, you have to distribute. So that gives me 6 times 2/3 f plus 6 times 1/2 is greater than 6 times 1/3. I'm multiplying everything by 6. So 6 times 2/3 becomes 2 times 2, which is 4f, plus half of 6 is 3, and that's greater than 1/3 times 6, which is 2. So that's right here. Now let's see. So now to solve it, I'm going to subtract 3 from each side. That gives me 4f is greater than negative 1. I'll divide both sides by 4. I get my final answer. F is greater than negative 1/4. Check it. You simply put that in for f. And I'm just going to see if that equals 1/3 because I'm checking the endpoint. So 2 times negative 1/4 becomes negative 1/6 plus 1/2 is greater than 1/3. But 1/2 equals 3/6 minus 1/6 is 2/6, which is 1/3. My endpoint checks. All right. Now we're not going to graph this one, but we could. We would just have a number line that had fractions on our number line. Thank you very much for bearing with me and my crazy smart board. So now that I've tested my patience today, I'll see you tomorrow. We'll work some examples. Bye-bye.